Hey guys, Mr. McKinney here, just going over our lesson on definite integrals. And I stole this PowerPoint from Mr. Jansen, so all the fun jokes and stuff like that are thanks to him. So yeah, maybe we're talking about integrals? No, definitely we're talking about integrals. Yeah, definite integrals. So that's what we'll be talking about for now. So let's take a look. You saw this slide in the last video where basically integrals can be broken down into two major parts of the family. There's indefinite integrals and then there's definite integrals. So Mr. Jansen's video covered indefinite integrals. Today we're going to be talking about definite integrals. The only difference being that you're going to have limits. You're going to have bounds on the integral, and we'll get into what that means. Now, the indefinite integral just undoes the derivative, and that's what the last video talked about. A definite integral is basically talking about area. If today is the first video you've watched all year, the 10-second summary of calculus is that derivatives basically mean slope, and that integrals, as long as they are definite integrals, basically means area. So there you go. That's calculus in 10 seconds. All right, so let's look at a practical example. So we've got this graph that shows the velocity versus the time. So let's think about a car that's driving at 75 miles per hour. Now, if I want to figure out how far it went, I want to know the distance. Now, let's think about the fact that if we start with a position graph, then we can take, if I start with a position graph, I can take the derivative and get the velocity graph. And if I take the derivative again, I would get acceleration. Now, we're given the velocity graph. So we're given this and asked what the position was, or what the distance, how far did it travel. So if I want to know how far the car traveled, let's think about it. So it's 2 hours at 75 miles per hour. It's pretty easy to see that the answer would be 150 miles. But let's see how that applies to calculus. So between hours 5 and 7, so 5 and 7 here on the x-axis, and then 75 miles per hour, it was a constant speed. Now, if we think about the area of this rectangle, so the area would be the length times the width. And if we think about the length, it would be in hours, so 2 hours, and the width would be 75 miles per hour. Sorry about that. So 2 hours times 75 miles per hour. The hours could cancel out, which would give me 2 times 75 is 150 miles. Basically, if I want to go the other direction, so if I know velocity and I want to know what the position is or the distance, instead of taking a derivative, we're going to go the other way and we're going to take an integral. And the integral can be calculated basically by finding the area underneath the curve. And we'll get into that in a lot more detail. This is just getting you to think about that. So this is the definition of a definite integral. So we're going to talk about all the different pieces. So you've got the number on the bottom is called a lower limit. The number on the top is called the upper limit. The function that's inside is called the integrand. And then whatever variable you have here is your variable of integration. So we want the integral from a to b of this function f of x. And if we want to calculate this definite integral, essentially we're just going to find the area under the curve. Now, note here that it's not actually the area under a curve, it's the area between the curve and the x-axis. Because if I think about a graph like this, let's say that this was my graph, and I wanted to know the area underneath the curve, well, it's infinite because it goes forever down. So we wouldn't be looking at that area. We'd be looking at the area between the curve and the x-axis. Now, it's important to know that when we're talking about integrals and when we're talking about definite integrals, they compute the net area. So we consider anything above the x-axis to be positive, and we consider anything below the x-axis to be negative. Now, a common problem on the AP exam is not going to ask you to find the net area, but is going to ask you to find the total shaded area. If you want to find the total shaded area, there's two things you can do. If you have a picture, you would just want to make any negative areas into positive. You just think about them as a positive value and then add them all together. Or what you can do is you can do the integral of the absolute value of your function. And we'll talk about that in a second. And we'd want some limits because we're talking about area. So we've got a sine graph here. It's going from 0 to pi to 2 pi. And we want to calculate two things. We want to calculate the net area, and then we're going to calculate the total shaded area. So the net area, we're going to look at area above as being positive and area below as being negative. So we'd have a positive 2 here, a negative 2 here, and altogether we would have 0. So another way to say that would be that the integral from 0 to 2 pi of sine of x dx is equal to 0. So the area under the sine curve between 0 and 2 pi is 0. Now again, that's because the area above is positive and below is negative. If I look at the total shaded area, then instead of considering this to be negative, we consider it to be positive, and I would just do 2 plus 2, and I would get 4 units is the total shaded area. Now, if I wanted to write that with an integral, everything's going to be exactly the same, except I want everything to be positive, so I'm going to put absolute value around the sign. So anytime it asks for total shaded area, the easiest way to do it, especially if you have a calculator, and we'll talk about that later on, is just to put absolute value around the function before you take the integral of it. So anytime you'll see absolute value around a function, it's going to find the total shaded area, not the net area. This is just getting you guys ready for the next day. But basically, if we're going to find the area underneath a curve, we're going to think about it as a bunch of different rectangles, and then we're going to shrink those rectangles down. So this is what we're going to be doing next class period. It's just getting you thinking about that. Today, we're not going to do any crazy curves. Everything will be what we're considering a geometric shape. So these are the 4 most common area formulas that you're going to need. Hopefully you already know these first 3 by heart and then memorize this one real quick. But you're going to use these formulas to help calculate the value of a definite integral. You're going to draw a graph and then figure out which of these shapes you've got and then find the area underneath the curve. Now again, remember that under is really between the x-axis and the curve. All right, so let's do some calculus. I want to know the value of the integral from -3 to 2 of 4 dx. So basically, I want to know what is the area under the curve, and the curve we're talking about here is this function. So y equals 4, the area under that curve from x equals -3 to x equals 2. The limits are always going to be values of this variable. So in this case, these are x values. So let's draw a graph. Y equals 4 is a horizontal line at 4. And I want to go from -3 to 2. So -3 to 2. Now I've created a rectangle. The entire rectangle is above the axis. I know that this is all going to be positive, so I don't have to worry about finding positive area and negative area. So the value of this is just whatever the area of this rectangle is. So the area for a rectangle is length times width. The length would be 5, and then the width was my height, which is 4. So 5 times 4 is 20. So the value of this integral, this definite integral, is 20. And you can do it on your calculator, and we'll talk about that later, but this would probably be on the non-calculator portion. It'd be on the multiple choice part. You're not going to have to show a whole lot of work. You might have to show an area calculation, but there's not going to be a ton of work that you would show on some of these. All right, let's get it a little bit more complicated. So this time, we want the area underneath the curve y equals -2x plus 4 between x equals 0 and x equals 2. So we're going to want to figure out what this graph looks like between 0 and 2, and then figure out what shape to get the area underneath it. So negative 2x plus 4, if I graph that, it's got a y-intercept of positive 4, and then a slope of negative 2. So down 2 over 1, down 2 over 1, down 2 over 1, and so on. Now, I only want the integral between 0 and 2, so I only want this part of the triangle, nothing on the left side of the y-axis and nothing past 2. So again, this is a triangle, so the area would be 1/2 base times height. So 1/2, the base has a length of 2, and the height has a length of 4. Now, one thing that will be helpful on some of these problems when they're not quite so easy is to figure out what these points are at the ends. So for example, plug in 0, 0 plus 4 gives me this point, and then plug in 2. Negative 4 plus 4 is 0. So that point is 2, 0. And you'll see in some of the later examples why it helps to plug in these endpoints. So the integral from 0 to 2 of negative 2x plus 4 dx is equal to 4. And on the AP exam, if you needed to show work, it would just be this triangle calculation. All right. Exact same equation, but this time we're going from 0 to 3. So we know we cross up here at positive 4. We've got a slope of negative 2, so we're going to cross here at 0. And then we're going to keep going down to over 1. So this is what my graph looks like. I only care about it between 0 and 3. So I'm talking about this triangle. And then where kids get confused is they start to draw here. But remember, we want between the curve and the x-axis. So we want this triangle. We already calculated that this triangle has an area of positive 4. So I don't know where that crazy line went. So positive 4 for this triangle. We need to figure out the area of this triangle. So 1/2 times the base times the height. In this case, the base is 1 and the height is 2, which cancels out and just gives me 1. But we need to think about this as a negative area because it's below the axis. So this would be negative 1. So when I find my answer, we have a positive 4 area and then a negative 1 area. So altogether, that would be an area of 3. So the net area, because remember, integrals calculate the net area, would be 3. Now, if I had this same problem and I went 0 to 3 of the absolute value of negative 2x plus 4 dx, now I just know that this piece would get flipped up, and so I would have 4 plus 1 would be 5. You would have two ways of doing this problem. You can either draw this picture and then just add 4 plus 1, or you could have asked, you could have actually graphed the absolute value, which would look like this, and then you would have positive area on both sides. So again, the integral will calculate the net area. If you want the total shaded area, that's when you're going to use absolute value around your function. All right, this next problem is a little bit more challenging, so I'm going to wait till the next video to do that one. So the main takeaway from this first video is that definite integrals calculate area, and derivatives talk about slope. That's calculus in 10 seconds. Integrals are area, derivatives are slope. Now you're ready for the AP exam. We might need to learn some more stuff first. All right, hope this helped.